Okay, guys, so what I'm going to do is I'm going to make a show me that demonstrates each one of these questions that is on that review packet that I gave you. So some of these will be short, some of them will be quick. The thing is, I wrote the number up here at the top that it's got. So this is reading question 10.3, for example. Some of them repeat, but you should just be able to scroll through and find it. All right, so on 10.3 it says mechanical energy is, and it is equal to all of the kinetic energy plus all of the potential energy in a system. So on the test, it will look like this: mechanical energy equals kinetic energy, not equals, plus elastic potential energy, EPE, plus gravitational potential energy, GPE. Alright, so you got to include all three of those things into mechanical energy, and the important thing is that mechanical energy initially should equal mechanical energy finally. We've seen this written also as energy initial equals energy final. Okay? Number 2, or rather 10.1, says you're launching a pebble. It's shot 25 meters per second, and we want to know how high it goes. So think about the types of energy: kinetic energy here, gravitational potential energy here. So we get gravitational potential energy initial, or rather final, should equal kinetic energy initial. Alright, because there's only kinetic energy here, and there's only gravitational potential energy there. Alright, so that means that mgh should equal 1/2 mv squared. So whenever we solve for this, you notice the m's cancel, so we're left with 10h equals 1/2 times 25 squared. So we should get this right here, 312.5, I believe, and then divide by 10, and h should be equal to 31.25 meters. That's how high it would go. There is a slight discrepancy on the paper because it's it used 9.8. Alright, so the next one, which one, 10.4, which one of those will have the greatest potential energy? It's got one, it looks like this, I think. Yep, there you go. Looks like that. Down, up, up. So the greatest potential energy should be this one right here. So 3 should have the greatest potential energy. Numbers 2 and 4 should be equal to each other. Maybe. 2 and 4 should be equal to each other, and number 1 should have the least potential energy because it's sitting on the ground. Because remember, potential energy is based upon height. So both of these have the same height, and this one has the greatest height, so it would have the greatest potential energy. Okay? So the answer should be D in this case. Alright, 10.6. A small child slides down 4 frictionless slides, and they look like this, then this, then this, and then this. Alright, the important thing here again is that all of these on the problem, you can see they all have the same height, which means they all have the same gravitational potential energy. And if there is no friction, which there isn't because it's a frictionless slide, then the gravitational potential energy should equal the kinetic energy, which means they should all hit with the same kinetic energy, and therefore they should hit with the same speed. So they should all be equal. So all of these should have the same speed for all of them. So VA equals VB equals VC equals VD. Alright, all the way down. Number 10.3. This is a repeat, but it's the speed of the sled. So Christine runs forward with her sled. So it looks like this at first. She's going 2 meters per second off the edge here. She is 5 meters above the ground. And what we're looking for is the speed whenever she is down here at the bottom. So what type of energy does she have? Here she has kinetic energy. Here she has both gravitational potential energy and kinetic energy. So what you're going to have to do is you're going to have to set these two things equal to each other. So gravitational potential energy initial plus kinetic energy initial should equal kinetic energy final. Does it matter that the girl is going out and then she's going to turn and do all kinds of things on the way down the hill? No, it does not. It just matters that she is going 2 meters per second. So mgh plus 1/2 mvi squared equals 1/2 mvf squared. And notice that the m's all cancel out, so it doesn't matter what the mass of the girl is. So we end up with 10 times 5 plus 1/2 times 2 squared equals 1/2 times vf squared. So we end up with 50, let's see, 52, I'm going to move it up here, 52 equals 1/2 VF, so you get 104 equals VF, and if you, or sorry, VF squared. If you square root that, you should get 10.2 meters per second equals VF. Okay, there you go. Number 10.7. So it shows that there are three different balls being thrown off, and they have different angles they're being thrown from, and it asks which one hits the ground with the greatest speed. But the important thing here is this: each one of these balls, if they leave with the same speed, they should have the same kinetic energy. So each of these has the same kinetic energy. They all leave from the same height, so they should all have the same gravitational potential energy. Alright, which means that all of their kinetic energy in the end should be equal to those two things added together, which means their velocity in the end should be those two things added together. Alright, so the answer should be they all have the same speed. Alright, 10.8. A hockey puck is sliding on smooth ice at 4 meters per second, comes to a 1 meter high hill. Will it make it to the top of the hill? The answer is no, it will not. And here's why. So first thing you can do, if you need to find the mass of the ball, you can. So I'll show you the way I would do this. If you want to, like if you don't know the mass and you want to use the mass but you don't have it, just plug in a number. Let's say this thing is 1 kilogram, okay? So this puck is 1 kilogram. It doesn't matter because the masses are going to cancel. But what we're going to do is we're going to show that if the puck is 1 kilogram, it will not be able to get up the hill. So the kinetic energy of the puck when it's going would be equal to 1/2 times 1 times 4 squared, which would mean that it's 8 joules of work, or sorry, 8 joules of kinetic energy. So that kinetic energy is going to have to be transferred into potential energy. At the top of that hill, that puck would have a potential energy of 1 times 10 times 1, which would be a potential energy of 10 joules. So the potential energy at the top would be 10 joules. The kinetic energy at the bottom it only has 8 joules. So since 8 joules is less than 10 joules, it can't get up the hill. It's going to be stopped short because it doesn't have enough kinetic energy to transfer into potential energy. Alright, 10.9. Restoring force of 3 strings or springs is measured as they are stretched. Which spring has the largest spring constant? Remember that force of a spring is equal to kx, which means that the slope is the k and the x is what you're changing. So x is in fact x. So if we're going to do y equals mx, m is k and x is just x, y would be f. So the steeper the slope, right, the bigger the m, the bigger the k would have to be. So A has the steepest slope, and so A would have to have the biggest k. Alright, so what we're going to do is we're going to stop there for right now, and then I will make the rest of the videos, or the rest of the problems in a second video later.